Okay, last section, 9.5, is talking about a new formula called Pythagorean Identity, which is right here. It won't be given, though, so you need to know it. And we're going to go back to Pythagorean theorem also. So let me just show you really quick the proof of how we got it. Okay, how we get this formula. You don't have to know how to do the proof. I just want to show you because it's kind of cool. So if you take a triangle and label it HOA, oops, and I need my theta, and then we could also label it A, B, and C from Pythagorean theorem. So my Pythagorean theorem is this equation right here, which in our picture, A is O squared, so little b is A squared, and little c is H squared. And if we manipulate the problem, just trying to rearrange it, let's say I want to get rid of this H squared over here. Remember, O over H is sine, so katoa. And then A over H is cosine. And then H over H is just 1. And that is how you can make the Pythagorean identity. So if you forget where it came from or what it is, like if I forget, is it sine squared or is it tan squared, you can use the triangle if you need to. Otherwise, we're just going to be using this equation. Okay, and it's to go from cosine to sine and back and forth. If I give you one, can I get the other? Okay, if you don't have one of them, you can set up a triangle if you need to, just to get sine or cosine. So take a look here, cosine, they gave you sine, that's the given. So start there and identify what you want to find. Okay, that's the key thing. So if they gave you sine and they want cosine, write the equation down, that's given. So sine, that's this guy, and see that squared? That means you have to square it. So now, when we square this, remember, distribute the square. So we get 4 times, and then radical 5 squared is just 5. So we do get 20 over 25. And then let me come over here so you can see it better. So we have 20 over 25 plus cosine squared equals 1. Now notice here, if I want to use this 1 in the fraction, we got to make this a fraction. So let's change that. So we've got 20 over 25 cosine. So I'm going to make this 25 over 25. Nice and simple. So now we can subtract the fraction to both sides. So that goes away. And we get cosine squared equaling 5 over 25 because of these denominators being the same. And then we square root because of that 2. So cosine by itself is radical 5, and then this guy becomes just a 5. And that's it. So the trickiest part is getting the 1 to become a fraction that you need. Okay, let's take a look at the second practice problem. See how this one, our given is tangent, and we're trying to find cosine. So if they give you tangent, we don't use this theorem. We use a triangle. And just put theta in a corner. Mark HOA. Now tangent, remember TOA was O over A. So O and A, we actually know. And cosine is a over h from SOHCAHTOA. And we have h, or we have a. We don't have h. So what we're actually going to do is do Pythagorean theorem on this. So we've got radical 3 squared plus 12 squared equals h squared. So we get 3. When you square a radical, you get 144. So h is radical 147. I'm going to keep the radical, but h isn't what we're finding. Remember, we want cosine. So cosine is a over h. So it's going to be 12 over radical 147. But then remember, let's move it upstairs really quick. So notice we found cosine without ever finding our angle. We didn't need to. And that is the point of Pythagorean identity.